Warm welcome to all of you. Continuing with our chapter P block element, and in that we were discussing about the phosphorus. Okay, so let's moving further, and here we are going to discuss about the compounds of phosphorus. Okay, compounds of phosphorus, and in that the first compound for phosphorus is phosphine. Okay, phosphine. The chemical formula for phosphine it is pH3. Okay, and it is termed as the hydride of phosphorus. It is nothing other than a hydride of phosphorus. So how it is prepared? What is the preparation method for phosphine? Let's have a look at this, that how phosphine is being prepared out. So preparation of phosphine, the first method is from phosphites. We can prepare phosphine from the phosphites. Okay, so from phosphide, by the action of water or dilute mineral acids, we can prepare from metallic phosphide the phosphine. Okay, for example, if I am taking calcium phosphide Ca3P2 and I am treating it with water, then it will produce calcium hydroxide and phosphine gas. Okay, also when treating calcium phosphide with dilute hydrochloric acid also, we will prepare calcium chloride and phosphine gas. Okay, also aluminium phosphide. Okay, we can take one more example for aluminium phosphide, which will react with hydrochloric acid, dilute hydrochloric acid, to produce aluminium chloride and phosphine. Okay, so these are some of the methods to prepare the phosphine from phosphides. The second method for preparing phosphide is from phosphoric acid. We can prepare phosphides from phosphoric acid, and here pure phosphine can be prepared here by heating phosphorus acid at 478 to 483 Kelvin, and the decomposition of phosphoric acid will take place here. Okay, on heating phosphoric acid at a temperature of 478 to 483 Kelvin, here the decomposition of phosphoric acid will take place, and phos phosphorus acid, sorry, this is phosphorus acid and it will convert to phosphoric acid and phosphine. Okay, next is from phosphonium salts. We can prepare phosphorus from phosphonium salts. So salts such as phosphonium iodide, okay, phosphonium iodide, when treated with caustic soda, okay, when treated with caustic soda in aqueous state, means solution of caustic soda is taken place here, is reacting here with phosphonium iodide. Okay, then phosphine will be released out here with sodium iodide, water, and phosphine. Okay, how to prepare this phosphonium iodide? So for preparing phosphonium iodide, phosphorus is been treated with iodine and water. So preparation of phosphonium iodide, hydrogen iodide, okay, and phosphoric acid takes place. The next is the laboratory preparation. Laboratory preparation. So for laboratory method, we will use white phosphorus with concentrated NaOH. Okay, we will take white phosphorus with concentrated NaOH in inert atmosphere of carbon dioxide. Okay, in inert atmosphere of carbon dioxide, it will produce sodium hydrophosphite and phosphine gas will be released out there. Okay. What is the structure for phosphine? Sorry, what is the structure for phosphine? The structure for phosphine is pyramidal. Okay, it is pyramidal. One lone pair of phosphorus here and three hydrogens with a bond angle of 93.6 between them and bond length of 142 picometer will be present out there. It is pyramidal structure. Okay, pyramidal structure. Here we will see that the P is been sp3 hybridized here. Okay, it is been sp3 hybridized. What are some of the properties of phosphine? Properties of phosphine. So number one, colorless gas with unpleasant rotten fish or garlic smell. Okay. Second, highly poisonous gas, highly poisonous in nature. Third, heavier than air. This gas is heavier than air and vapor density of this gas is 17 and is slightly soluble in water also. Slightly soluble in water also. At 185.5 Kelvin, it becomes liquid. Okay, means it condenses to liquid, and at 139.5 Kelvin, it forms solid. Okay, it gets solidified at temperature of 139.5 Kelvin. Okay. Next, chemical properties. So, what are some of the chemical properties for phosphine gas? So, in chemical property, first, litmus paper. Okay, reaction with the litmus paper. How it reacts with litmus paper? Action with litmus. So, it is feebly basic. Okay, it is feebly basic and reacts with halogens to form a phosphoric salt here. Okay, it is feebly basic means it is very low basic in nature, and with halogens it will form salts such as phosphonium halides. Okay, it will form phosphonium halides. Okay, one example we can take for here, PS3 plus HBr, it will form PH4Br, that is phosphonium bromide. It is incombustible. Okay, it is incombustible, but when heated to 423 Kelvin, okay, it is incombustible, but when heated to 433 Kelvin and in the presence of air or oxygen, it burns to form phosphoric acid. Okay, it burns to form phosphoric acid, means it gets oxidized. Okay, above 423 Kelvin, it will get oxidized to phosphoric acid on heating. Third, it decomposes to uh, tetraphosphorus at 713 Kelvin in the absence of air. In the absence of air, it decomposes to P4 and H2. Okay, it reacts with chlorine. Okay, it reacts with chlorine, uh, but to form trichlorides and pentachlorides. Okay, to form trichlorides and pentachlorides. So for forming trichloride, three chlorine atoms will be reacting with it. PCl3 HCl will be formed out. Okay, and for pentachloride, 5 chlorine will be reacting with it. Sorry, 4 chlorines will be reacting with it to form pentachloride and 3 Hs. Okay. So these were some of the properties, chemical properties for phosphine gas. How phosphine is being useful to us? What are the uses of phosphine? Okay, so let's see the uses of phosphine. So phosphine, it is used in preparing Holmes signal. Okay, used for preparing Holmes signal for ships to know about the position of rocks in the sea. In the sea. Okay. Also, it is used to produce smoke screen, smoke screen in warfares. Okay, in warfares it is used for producing smoke screens. Okay. Let's see the next compounds of the phosphorus, that are halides of phosphorus. Halides of phosphorus. What are the halides of phosphorus? So first, PCl3, the first halide of phosphorus, that is pentatrichloride. Okay. So how it is been prepared in laboratory? We can prepare it by simple method of P4 plus 6Cl2. It will produce 4PCl3 here. Okay. But the receiver which protects from the reduction film. Okay, for distillation process here, for this particular preparation, after this preparation, we have to distill it here. Okay. Because for preparing this Cl2, it is very hard to obtain this Cl2 in its natural state. Okay, in free state. So for that, we will react it with thionyl chloride. Then PCl3 will be formed out here, where sulfur dioxide gas and S2Cl2 gas will released out there. So here reaction of white phosphorus. Okay, reaction of white phosphorus is taking place with thionyl chloride. Thionyl chloride, and this is white phosphorus. White phosphorus. So due to this reaction between white phosphorus and thionyl chloride, phosphorus trichloride will form out. What is the structure? The structure is similar to that of the phosphine only. T chlorine, 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 but the angle here will be larger as comparison to that of hydrogen one, because here the size of chlorine is large. So due to that reason, the angle between the chlorine atoms here, it will be larger as comparison to that of the phosphine. Okay, but the bond length is nearly similar to that of hydrogen. Okay, and it is also forming a trigonal, pyramidal structure. It is also forming a pyramidal structure. What are some of the properties of PCl3? So first, colorless oily liquid. It is a colorless oily liquid. Fuming constantly. Fuming constantly in moist air. It is fuming constantly in moist air. The specific gravity for PCl3 is 1.6 and the boiling point is 347 Kelvin and the freezing point is 161 Kelvin for PC. Okay, and it has pungent smell. Okay, it has a pungent smell. It will produce pungent smell. What are some of the chemical properties of PCl3? Chemical properties of PCl3. So what are some of the chemical properties of PCl3? Number one, reaction with water. So how PCl3 reacts with water? So PCl3 forms phosphorus acid when reacted with water. Okay, it forms phosphorus acid. It fumes in moisture and reacts with water violently to form phosphorus acid. Okay, it generally does not react with water, but in its fuming state, in the moist air, it reacts with water to form phosphorus acid. Okay, the reaction with atmospheric oxygen. Reaction with atmospheric oxygen. 2PCl3 plus O2 will give 2POCl3, that is phosphorus oxychloride. Okay, phosphorus oxychloride. Third, action with chlorine and sulfur. How it will react with chlorine and sulfur? React with chlorine and sulfur. So when PCl3 is further reacted with chlorine, it will convert to pentachloride, phosphorus pentachloride. And when PCl3 is reacted with sulfur, then it converts to thiophosphorus oxychloride. Oxychloride. Okay. Its reaction with organic compounds. Reaction with organic compounds. So PCl3 reacts with acetic acid. Okay, acetic acid to form acetyl chloride and phosphorus acid. Also, it can react with alcohols, that is ethyl alcohol to form haloalkanes. Okay, haloalkanes can be prepared by this method. And chloride. Okay, as I am taking chlorine here. Okay, chlorine is being present here, so ethyl chloride will be formed out here by when we are reacting phosphorus trichloride with ethyl alcohol. Okay, so these were some of the properties of phosphoric trichloride. Okay, phosphorus trichloride. What is its main uses? Its main uses is to be used as reagent. Okay, it is used as reagent for replacing the halide groups from the OH group from the alcohol. Next is the PCl5. PCl5. So the preparation. First is the preparation. How it is been prepared. Okay, so the preparation, P4 plus 10 chlorides, it will give 4 PCl5. Okay, also as we have seen in the previous topic that from phosphorus trichloride also we can prepare phosphorus pentachloride. Okay, the structure is bipyramidal. Okay, the structure for phosphorus trichloride is bipyramidal. How it is structure? 1, 2, chlorine, 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 one chlorine 90° upward, one chlorine 90° downward, and these three chlorines are in a single plane, okay, in the triangular structure. So it is bipyramidal structure, bipyramidal structure. Okay. What are some of the properties of phosphorus pentachloride? Yellowish white powder, yellowish white powder, having pungent smell. Okay, it has pungent smell just like that of PCl3 only. Next, fumes in moist air, fumes in moist air due to its strong affinity for water. Okay, it generally reacts with water violently, so therefore it generally fumes in moist air. The melting point is 318 Kelvin and the sublimation point, sublimation temperature is at 433 Kelvin. Okay, let's move further and see its chemical properties. It is very highly reactive, and thermally it is very less stable, and it decomposes to PCl3 and Cl2. Okay, how it reacts with water? So generally it reacts with water like this: PCl5 plus H2O. It will produce phosphorus oxychloride and hydrochloric acid. CS3 COOH plus PCl5 means a reaction of phosphorus pentachloride with organic compounds. Here we will produce acyl chloride, phosphorus oxychloride and hydrochloric acid. With alcohols C2H5OH, the replacement of hydroxyl group with chloride will take place here, and formation of ethyl chloride, phosphorus oxychloride and hydrochloric acid will take place. Okay. How it reacts with metals? Its reaction with metals 6PCl5 when reacted with silver, it will produce silver chloride and PCl3. Similarly, it will react with tin to produce tin chloride and PCl3. Okay. So these were some of the reactions of pentachloride of phosphorus and trichloride of phosphorus. In the next class, we will continue further and we will take out the oxides of phosphorus, which is one of the most important part of the phosphorus. And after that, we will move to the 16th group elements and study about the chemistry of the 16th group elements. So thank you for today. We will continue this class in this chapter in the next class. Thank you.